Let us look at the different types of probability. There are 4 different types: the classical approach, the relative frequency approach, subjective approach, and axiomatic approach. So in the classical approach, probability is defined as number of favorable events or outcomes over the total number of favorable outcomes over the total number of outcomes. Let us take an example to understand. Let us say we have a deck of cards, 52 in number, and let us say we want the probability of getting a red card, drawing a red card. We want to draw a red card and we want to know what is the probability of getting a red card. Now how many red cards are there? There are 26 red cards, 13 diamonds and 13 hearts. So total we have 26 red cards. So the probability of getting a red card is the number of favorable outcomes are 26 and the total number of outcomes are 52. So when we draw a card, the favorable number of red cards is 26 and the total number of cards is 52. So the probability of getting a red card, P of R, is 26 over 52 or 1 by 2. Later in the video you may see this as another number like 13 by 52, but that was a mistake. I have corrected it and the video has been edited. So you may see some other number in the later part of the video, but the probability of drawing a red card is, the correct answer is 26 over 52, and that's 1 by 2. So this is the definition of probability. This is how we calculate the probabilities in classical approach. Similarly, the probability of getting a king, let us say king card. How many king cards are there? There are 4 possibilities. So 4 favorable cards which have king out of a total of 52. So this is 1 by 13. So this is how probability is calculated in classical approach. But in classical approach, some practical points are disregarded. Like for example, in a coin toss experiment, in classical approach we say we either get a heads or a tails, but we never consider the chance that the coin may stand on its edge. Though the probability of something like this happening is very low, but still it is a possibility and classical approach disregards it. This may not be a problem when we are tossing coin experiment, but in business we need to know what is it we are overlooking by having a simplistic approach. In that case we go for there is another approach called relative frequency approach. What is this relative frequency approach? In relative frequency approach, before we go to relative frequency, let us go back to classical approach. In classical approach, what we do, we are able to calculate the probability without actually doing the experiment. We don't have to do the experiment. With the information we have, we are calculating the probabilities. But this may not be always possible in real life. For example, let us say there is an insurance company and they want to know what is the chance of an applicant, somebody has applied for health insurance or life insurance, and they want to know what is the chance that this person lives till the age of 70. In classical approach, we can do the experiment or we have prior data and we can do the calculation. But in this case, we don't know what is the chance of this person living till the age of 70. So in this case, what do they do? So what do they do is, you collect lot of data about lot of people, and then you, based on the number of people who lived beyond the age of 70 with the same demographics, with the same situation, then we can come up with some probability. So this is called relative frequency approach. So they collect all the past data and then you calculate the probabilities. But the downside of this relative frequency approach is we have to do a large number of trials, or we have to gather large number of data in relative frequency approach. This is how an insurance company in England was calculating premiums for the citizens there. Somebody had collected all the births and deaths of had collected them and put them in a register. So they were using that data to calculate relatively what is the chances of somebody living beyond a certain age, and then they were using that data to calculate the premiums. So for this, in the relative frequency approach, what do? We do a lot of either we go in relative frequency approach, we go for past data, or we do an experiment. We do an experiment, several number of trials. We do a large number of trials, and then then collect what are all the number of events that were favorable over the total number of trials, favorable number of outcomes. So this is the relative frequency. So let us say let us apply this for a coin toss experiment. Let us say when we toss a coin, we may get a head, and the next one also we may get a head. We never know. But after a certain number of, initially the number of heads may be disproportionate to the number of tails. Maybe we get 20 heads and 10 tails. But as the number of trials increase, then what happens? It will, at some point, it starts stabilizing and the probability will be tending towards 1/2. But for this, we have to do a large number of trials, and this is the relative frequency approach. What is the downside of, what are the disadvantages of going to this approach? Is the drawback is it requires the event to be capable of being repeated large number of times. We should be able to repeat an experiment several number of times, and also we are not sure how large this number should be. So what is that number where it stabilizes? We are not sure. So these are the two downsides. And then there is another approach called the subjective approach. In subjective approach, what happens is, let us say in the relative frequency approach, we were talking about large number of trials, but the relative frequency approach may fail with unique situations where that particular situation has not occurred in the past, so there is no past data, or because of the cost involved in doing the trials, we may not be able to do those experiments. Like for example, let us say we are testing a car crash. We cannot actually crash a car because it would be expensive, or we are testing an aeroplane, so we cannot do that. So we have to take a different approach, and that's where the subjective probability comes in. So subjective probability deals with unique situation, and they are based on some belief or educated guesses of the decision maker. Here what happens is, somebody who is deciding, who is the decision maker, with his intelligence, past experience, and then past events, maybe directly related or indirectly related, using these and some intuition, some gut feeling, he comes up with a number. So this approach, where a person makes the probability, tells a number based on his intelligence, experience, events, intuition, gut feeling, that is called a subjective approach. Subjective probability is defined as the probability assigned to an event by an individual based on whatever evidence is available. Now, in real life, if you see, there are two investors, Warren Buffett and Charlie Munger. These people were able to, when everybody in the industry, these people are investors, stock investors. They are Americans, and they are among the top richest people who have made billions of dollars by investing in companies. And they pick companies from their wisdom, from their intuition, experience, and past knowledge. So this is how they have used subjective probability to pick companies. And then the fourth approach is the axiomatic approach. In this approach, the probability of any event is calculated on the basis of certain axioms or rules. So there are certain rules, and we calculate the probability based on those. What are those rules? The rules are, first one, the probability of a certain event. The probability of a certain event is 1, and the probability of a totally uncertain event is 0. And the probability of the whole sample space, and also the sample space, the probability of all the sample space is 1, meaning that this sample space contains all the possible outcomes. And when there are two events A and B and they are mutually exclusive, and the third axiom is when there are two events A and B and they are mutually exclusive, then either A or B happening is P of A or B is probability of A plus probability of B. So the axiomatic approach uses these rules to calculate the probability. This is an introduction to probability, and going forward we'll take up the next topics and do some actual problems.